Good day to everyone that is watching. This is a cloud computing presentation by myself, Alan Mohendo. What is cloud computing? Cloud computing is a model for delivering computing services over the internet, providing convenient, on-demand access to a shared pool of configurable computing resources. These include servers, storage, applications, and services. These resources can rapidly be provisioned and released with minimal management effort or service provider interaction. Characteristics of cloud computing include on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Cloud computing has revolutionized the way businesses and individuals consume and deliver computing services, providing a flexible, scalable, and cost-effective alternative to traditional on-premises IT infrastructure. Advantages of cloud computing include cost savings, scalability, flexibility, reliability, and a faster time to market. There are three main computing service models. These include infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service provides virtualized computing resources over the internet, such as servers, storage, and networking. Platform as a service provides a platform for developing, running, and managing applications without the complexity of building and maintaining the underlying infrastructure. These include Google App Engine and Heroku. Software as a service provides access to software applications over the internet, and this eliminates the need for customers to install and run the applications on their own computers or infrastructure. Examples of these are Google Workspace, formerly G Suite, Microsoft Office 365, and Salesforce. With the help of virtualization and creating user access policies, cloud computing services can be provided by cloud vendors. If a user needs software as a service, vendors give permission to the user to access just the software level, and the other levels will be supported and managed by the cloud providers. Likewise, if you need the platform or infrastructure services, the provider gives the permission to access more layers involved in the cloud computing systems. In addition to these main service models, there are also some variations and subsets given below. We have desktop as a service. This is where the providers provide virtual desktops to users over the internet, allowing them to access their desktops from any device with an internet connection. We also have function as a service, which is known as the serverless computing, and this allows developers to run individual functions or pieces of code in response to events or requests without the need to manage the underlying infrastructure. Other cloud computing service models include virtualization platforms, which enable the creation and management of virtual machines on physical servers, and service-oriented architectures. The architectural approach for building software systems based on loosely coupled services. We have four types of deployment models. These include private cloud, which is dedicated to a single organization and can be managed internally or by a third party. Public cloud, which is shared among multiple organizations, owned and managed by a service provider. Community cloud, which is shared by several organizations with a common concern or requirement. And hybrid cloud, which is a combination of the two or more clouds, i.e., private, public, or community. Cloud service providers usually ensure security with the data encryption, access controls, and compliance with security standards. They have sufficient data storage, backup, and retrieval mechanisms in the cloud. And they ensure compliance with the data privacy regulations, service level agreements, and data jurisdiction. Comparison between the cloud computing service models. Local resource requirements. Infrastructure as a service requires minimal local resources, as most resources are provisioned in the cloud. Platform as a service requires minimal local resources, primarily for application development and deployment. Software as a service requires minimal local resources as applications are accessed through the web browser. Local control. Infrastructure as a service requires a high level of control over the operating systems, storage, and deployed applications. Platform as a service requires control over the deployed applications and possibly the hosting environment configurations. Software as a service requires limited control as the provider manages the entire software stack. Network requirements. All the three, infrastructure, platform, and software as a service, require reliable and fast internet connectivity for accessing cloud resources and services. The biggest security issues in cloud computing are the potential privacy risks. While there are benefits, there are privacy and security concerns too. Data is traveling over the internet and is stored in remote locations. In addition to this, cloud providers often serve multiple customers at the same time. All of this may raise the concern of exposure to possible breaches, both accidental and deliberate. Concerns have been raised by many that cloud computing may lead to function creep. This is the use of data by cloud providers that was not anticipated when the information was originally collected and for which consent has typically not been obtained. Infrastructure as a service, its overall vulnerability depends on the customer's security policies. There are vulnerabilities in the operating system and applications deployed by the customer. These can be mitigated by proper configuration, patching, and security measures implemented by the customer. Platform as a service. The overall vulnerability is shared between the customer and the service provider. There are vulnerabilities in the deployed applications and possibly the hosting environment. This can be mitigated by securing coding practices, regular updates, and security features provided by the platform. Software as a service. The overall vulnerability is largely dependent on the provider's security practices. There are vulnerabilities in the software application and underlying infrastructure. These can be mitigated by having robust security measures implemented by the provider, such as data encryption, access controls, and regular updates. These are the references. Thank you very much.